Deep beneath the ocean surface, powerful machines are cutting through the seabed to build the world's hidden infrastructure. Some of these subsea trenchers weigh over 60 tons. These incredible machines are shaping the future of energy beneath the sea. Hidden beneath offshore construction sites, the Subsea trencher performs a job that keeps global communication and energy networks running safely. These machines can weigh over 30 tons and are capable of burying subsea cables up to several meters below the seabed to prevent damage from fishing equipment and ship anchors. Lowered carefully from a support vessel, the trencher moves across the seabed, while powerful water jetting tools loosen sediment and create a precise trench where cables can be safely installed. Operating hundreds of meters underwater, the machine is remotely controlled by engineers on the surface who monitor every movement in real time. This technology allows offshore cable installation to be completed faster, safer, and far more efficiently than traditional excavation methods. In the rapidly expanding world of offshore energy and global communication, machines like the Subsea trencher are quietly shaping the infrastructure of the modern world. Deep beneath offshore wind farms and subsea cable routes, the Osbit PLP240 subsea plow performs a critical job that keeps global energy networks protected. This enormous trenching system can weigh nearly 240 tons and is designed to bury subsea cables several meters below the seabed to ensure long-term protection. Towed behind a powerful offshore vessel, the PLP240 slices through sand and sediment using a massive steel plow blade that opens a precise trench while simultaneously guiding cables safely into the seabed. By significantly reducing installation time compared to traditional excavation techniques, the Osbit PLP240 has become a key tool in the rapid expansion of offshore wind energy and subsea power transmission around the world. Far beneath the ocean surface where human divers cannot reach, the SMD Subsea trencher is designed to build and protect critical offshore infrastructure. These massive robotic machines can weigh more than 50 tons and often cost well over $8 million, making them some of the most advanced construction vehicles operating underwater today. Deployed from a specialized offshore vessel, the tracked vehicle moves slowly across the seabed, while powerful cutting chains or high-pressure jetting arms carve trenches that can reach depths of 3 meters or more. This allows pipelines, fiber optic cables, and offshore wind power connections to be safely buried beneath the seabed, protecting them from anchors, fishing equipment, and strong ocean currents. The Inshore Subsea trencher performs one of the most critical jobs in offshore engineering. Built for deep-sea construction, these powerful robotic machines can cost more than $5 million and often weigh over 40 tons while operating hundreds of meters below the surface. Deployed from a specialized support vessel, the tracked vehicle slowly crawls across the seabed, while powerful cutting tools or high-pressure jetting systems carve trenches that can reach depths of 2 to 3 meters. This allows subsea pipelines, fiber optic cables, and offshore wind farm connections to be safely buried beneath layers of sediment, where they remain protected from anchors, fishing gear, and powerful ocean currents. Efficient, precise, and incredibly powerful, the Inshore Subsea trencher proves that some of the world's most impressive engineering happens far beneath the waves. In the silent depths of the ocean, where offshore power cables and pipelines must remain protected for decades, the Royal IHC hi-traq trencher gets to work. This advanced subsea vehicle can weigh over 30 tons and is capable of burying cables more than 3 meters beneath the seabed, ensuring critical infrastructure stays safe from anchors and fishing gear, using powerful tracked systems, while high-pressure water jetting arms fluidize the sediment to create a precise trench. This method allows cables to sink safely beneath the seabed with remarkable efficiency and minimal environmental impact. Designed for offshore wind farms and long-distance power transmission projects, the Royal IHC hi-traq trencher plays a vital role in building the underwater energy networks powering the modern world. Installing subsea cables and pipelines in deep ocean environments requires machines built for extreme conditions, and the IKM Subsea Trencher is designed exactly for that challenge. These powerful trenching systems can weigh more than 35 tons and operate hundreds of meters below the ocean surface while carving trenches that can reach depths of around 2 to 3 meters. Lowered from offshore vessels and controlled remotely by operators on the ship, the machine crawls slowly along the seabed, while powerful jetting systems loosen sediment and create a trench for cables or pipelines to settle safely into place. This process protects vital offshore infrastructure from shifting seabeds, anchors, and harsh ocean currents. The IKM Subsea Trencher ensures that the hidden networks carrying electricity, oil, gas, and global data. At first glance, it looks like a massive cargo ship, but the trailing suction hopper dredger is actually one of the most powerful seabed excavation machines ever built. Some of these giants can cost more than $100 million and carry over 30,000 cubic meters of sand and sediment in a single load. Using enormous suction pipes that extend to the seafloor, the vessel vacuums up sand, mud, and gravel while sailing slowly across the seabed. The collected material is stored inside the ship's giant hopper before being transported and released to deepen harbors, create artificial islands, or protect coastlines from erosion. Operating with incredible efficiency, these dredgers can reshape entire coastlines and construct massive land reclamation projects. From building ports to creating new land in the sea, trailing suction hopper dredgers are among the most powerful earth-moving machines ever deployed on water. When subsea cables need to be buried quickly and precisely, the T1000 jet trenching ROV is built for the task. This advanced remotely operated vehicle uses powerful jetting systems capable of producing extremely high-pressure water streams that fluidize seabed sediment and create trenches for cable installation. The system can operate hundreds of meters underwater and is designed to install cables at burial depths of up to around 2 meters depending on seabed conditions. Controlled remotely from a surface vessel, the T1000 moves with remarkable precision while guiding cables safely beneath the seabed, where they remain protected from anchors, currents, and fishing equipment. Compared to traditional trenching machines, jet trenching systems like the T1000 offer faster deployment and highly efficient cable burial in soft seabed environments. In offshore engineering, this powerful robotic system proves that sometimes precision and speed matter just as much as raw power. The Boskalis subsea dredger is a 40-ton engineering marvel built to tame the ocean floor. Powerful currents, shifting sediment, and stray anchors constantly threaten the vital cables that keep our world connected. But this machine is up to the task. With immense hydraulic power and precise remote control, the dredger navigates unpredictable waters, quietly safeguarding the electricity, data, and communications networks that span continents. Some trenchers rely on efficiency and flexibility, but the SMD MD3 is built around one defining characteristic: power. Weighing more than 60 tons, this enormous subsea vehicle is designed to handle seabed conditions that would stop many other machines. After being carefully deployed from a large offshore construction vessel, the MD3 settles onto the ocean floor and begins its slow advance using powerful tracked systems. At the front of the machine, a massive cutting chain rotates with tremendous force, slicing through dense clay and compact sediment that may have remained undisturbed for centuries. As the machine moves forward, it carves trenches more than 3 meters deep, creating secure pathways for pipelines and power cables. After a pipeline or subsea cable has been installed, leaving it exposed on the seabed is not an option. Ocean currents, fishing gear, and heavy ship anchors can all pose serious risks to unprotected infrastructure. To solve this problem, engineers use the Bisso backfill plow, a massive subsea tool designed to restore the seabed after installation work is complete. Weighing more than 50 tons, the plow is towed slowly behind a powerful offshore vessel as it moves along the pipeline route. Its large steel blade pushes sand and sediment back into the trench, covering the newly installed pipeline in a protective layer of seabed material. By restoring the natural seabed and protecting vital pipelines, the Bisso backfill plow plays a crucial role in ensuring the long-term safety of offshore energy networks. Behind many subsea trenching operations stands an equally important piece of technology on the surface: the offshore construction vessel. Companies like Damen shipyards design advanced ships specifically for supporting complex underwater engineering projects. These specialized vessels can cost well over $100 million and are equipped with powerful cranes, deployment systems, and dynamic positioning technology that allows them to remain perfectly stable even in rough ocean conditions. When a subsea trencher is ready to be deployed, the vessel carefully lowers the machine hundreds of meters down to the seabed. Once in position, operators inside the ship control the equipment remotely, while powerful trenching tools begin cutting into the sediment below. This combination of precision ship positioning and advanced subsea machinery allows massive offshore cable installation projects to be completed with remarkable accuracy and efficiency. The Boskalis multi-purpose subsea trencher is a powerhouse built to conquer one of the harshest workplaces on Earth: the ocean floor. Adaptable and precise, this engineering marvel rolls forward on heavy-duty tracks, carving controlled paths through sand, mud, and rock. High-pressure jets fluidize softer sediments, while mechanical cutters tackle tougher layers, creating trenches where pipelines and cables can be safely positioned. Every movement is monitored remotely, using real-time sensors and cameras to maintain perfect depth and alignment. With unmatched versatility and power, the trencher ensures that the energy and communication networks connecting continents are installed and protected, even in the most unforgiving underwater environments. Deep beneath offshore construction vessels, another specialized machine works quietly on the seabed: the Travocean TM05 trencher. Designed specifically for cable burial operations, this system focuses on precision rather than brute force. Controlled remotely from a support vessel, the machine moves steadily across the ocean floor, while powerful jetting systems release high-pressure streams of water into the sediment. The jets loosen the seabed and create a narrow trench that allows power cables to settle naturally beneath the surface. Operating in water depths reaching hundreds of meters, The TM05 carefully buries cables to depths of around 2 meters, protecting them from anchors, fishing equipment, and strong ocean currents. Though it works out of sight beneath the waves, the TM05 plays a vital role in building the hidden networks that carry electricity and data across oceans and continents. From giant track trenchers to high-pressure jetting robots, these incredible machines are doing some of the toughest engineering work on Earth, far beneath the ocean's surface. They protect the pipelines, power cables, and communication lines that keep the modern world running every single day. If you enjoyed seeing these amazing subsea machines in action, make sure to subscribe to Mighty Machine for more powerful engineering and heavy machinery videos from around the world.